Hello and welcome to In Simple Terms with Satish. Today, let's learn how weather prediction works. Your weather app looks simple. A temperature, a cloud icon, a 60% chance of rain. But behind that tiny forecast is one of the most impressive everyday engineering systems we use. The app is not just looking out the window. It is compressing sensors, data pipelines, physics simulations, probabilities, real-time updates, and product design into one small decision screen. The first layer is observation, sensing the atmosphere right now. Some instruments feel the air at ground level: temperature, wind, pressure, humidity, visibility, and rain totals. Weather balloons and aircraft sample the air above us. Radar watches where precipitation is falling and how it is moving. Satellites watch clouds, moisture, storm growth, and lightning from above. The second layer is data assimilation. Think of this as the forecast system's check-in moment. It takes messy real-world observations, quality checks them, compares them with the model's last guess, and builds the best starting snapshot of the atmosphere. That snapshot matters because the atmosphere is chaotic. Move a boundary of humid air a few miles. Change the timing of afternoon heating by a little. Shift a storm cell slightly north. Suddenly, one neighborhood is dry while another gets soaked. The third layer is numerical weather prediction. A forecast model divides the atmosphere into a giant 3D grid and uses physics to move air, heat, water vapor, pressure, and clouds forward in time. It is not magic, it is a huge simulation. The fourth layer is ensembles. Engineers and forecasters do not trust only one future. They look at many plausible futures. Some start with slightly different initial conditions. Some represent model uncertainty differently. If most versions bring measurable rain near your location, the rain probability goes up. If the versions split, the app may show a middle number like 40%, 50%, or 60%. That is where the familiar percentage enters. In National Weather Service language, probability of precipitation means the chance that a forecast point will receive measurable precipitation during a forecast period. For rain, measurable usually means at least 0.01 inch. So 60% is not the main technology, it is the output of the technology. It is a compact risk score from a sensing and simulation pipeline. A useful mental model is this. If the same weather setup happened 10 times, a 60% forecast says your location should get measurable rain in about 6 of those cases. The fifth layer is nowcasting. For the next hour or two, current radar and satellite trends can be especially powerful. If a line of storms is already moving toward you, the app can update quickly. If storms are only beginning to form from heat and humidity, uncertainty stays higher. The catch is that weather apps compress all of this into one neat number. They have to map a forecast grid to your phone's location, choose a time window, blend different data sources, round the probability, and turn uncertainty into a tiny icon. That is why two apps can disagree. They may use different models, update cycles, thresholds, or post-processing. The engineering lesson is bigger than weather. A 60% rain forecast is a user interface for uncertainty. Behind it are sensors, data pipelines, simulations, probabilistic models, real-time updates, and product decisions about how much uncertainty a human can actually use. In simple terms, weather prediction is a real-time computing system for the atmosphere. It collects the current state, simulates possible futures, measures uncertainty, updates with live evidence, and turns the result into something you can act on. That is the quiet genius of weather technology. It does not remove uncertainty. It makes uncertainty usable. If this helped you understand the topic in simple terms, follow or subscribe to In Simple Terms with Satish and share this episode with one friend who likes technology. I will see you in the next episode.